Okay, so let's talk about applications of trig identities. This time we're going to simplify and verify some identities. So let's just do a quick review, right? So the identities we have so far are reciprocal, right? So cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tan, and the reciprocals, right? So sine is 1 over cosecant, cosine is 1 over secant, and tan is 1 over cosine, or cotan, right? We have the quotients, so tan is sine over cosine, and cotan is the reciprocal, so cosine over sine. And then we have the Pythagorean, right? So sine squared plus cosine equals 1. And we learned before, if we divide everything by sine squared, right, we'll get 1 plus cotan squared equals secant squared, or cosecant squared. That's how we get this. Divide this whole thing by cosine squared, you'll get a tan squared plus 1 equals secant squared. All right, so that's how we generate those two. And then last are our opposite angle. So sine of a negative theta is negative sine theta. Cosine negative theta is just a positive cosine theta. And since tan is sine over cosine, it's going to be a negative over a positive, so it's going to be a negative. All right? Okay, so that's what we have to work with. Let's start. We want to first simplify this expression. So we have sine over tan. And for better or worse, there are lots of ways you can approach these. All right? So what I like to do is, well, in this case, since there's no addition, subtraction, it's all just multiplication and division, I just like to convert each piece, right? So I'll notice that sine doesn't simplify down at all, but I have 1 over tangent, right? So 1 over tangent is cotan. So this will turn into sine times cotan. And then once I get to, something that's on the same level, so no denominators, I like to just convert everything to sine and cosine. So I'll convert cotan into cosine over sine. Notice that the sines divide out and we're left with cosine. So this sine divided by tan is really the exact same thing as cosine. So in whatever application or model that was developed, if it came out to be sine over tan, you wouldn't use that. You'd use cosine instead, simplify it. Okay? All right. The other way we could do it is, let's just change everything to sine and cosine. So sine is sine and tan sine over cosine. So I do that little trick. Divide by a fraction is the same as multiplying by its reciprocal, and then you'll see the signs divide out, and I'm left with cosine. Okay? All right, like I said, multiple ways to do these. So you kind of, you develop a process that you like, and you just keep applying it. And if it works, great. If it doesn't, then change your process, right? Okay, so let's stop this, do classwork problems 1 through 3. Okay, so now let's simplify this expression. So unlike the previous one, there's actually an addition sign between two trig functions, and there's a square here. Well, first thing I would look at is sine and cosine. I'm not going to get that simplified at all. Like I can't be any simpler than sine and cosine. So I'm not going to do anything with these. And there's no identity that's sine plus cosine. So the only thing at my disposal is squaring. So in my mind, I call these the algebra ones. The only thing I can do is the algebra, right? So I'll do sine plus cosine squared. So that's sine plus cosine times sine plus cosine. So sine times sine is sine squared. Sine times cosine is sine x. Well, we just say sine cosine, right? And then cosine times sine is cosine sine. I wrote it as sine cosine, right? Since it's multiplication, you can put it in any order you want. So, because I'm going to eventually add it to this other one. So I might as well make it look the same. And then cosine times cosine is cosine squared. Well, I have these two I can put together, and notice I have a sine squared and a cosine squared. So I have a sine squared plus cosine squared, and then I have a 2 sine cosine. Well, sine squared plus cosine squared is 1, so that'll simplify to 1 plus 2 sine cosine. Okay, and from our identities, we don't have anything yet that can reduce this, right? So we just have to keep it 1 plus 2 sine cosine. All right? Okay. So you want to stop the video and do classwork problems 5 and 6. Okay, now we're going to get into verify identities. And the good thing about verify, so I'm not just simplifying, I'm trying to verify that the left side equals the right side. And the beauty of this is we have an equal sign. So that opens up options, right? We don't have to just work on one side at a time. We can actually do things to both sides. All right, so to verify, this is, again, gets a little weird because there are multiple ways you can go about verifying these. And depending on the direction you take, your end result might be different than someone else's. Okay, but you'll know you're at the end when you verified it when it's obvious to anybody looking at it that the left side equals the right side. Okay, So if left side equals right side, again, if it's obvious to anybody, not you, anybody, anyone can see that 2 equals 2, right? They can compare the numerical value of 2 and the other one, right? So let's start. Here I have equal sign. So instead of working on the side, I want to get rid of this denominator. And again, this is just one way to approach it. So I'm going to multiply both sides by cotan. Well, if I do that, then I get cosecant equals secant times cotan. And now I'm going to try to simplify the right side like I did in previous ones and see if it equals the left side. So what I'll do is I'll change the left side to 1 over sine. I'll change the right side to sines and cosines. And then you'll see the cosines divide out. So 1 over sine equals 1 over sine. And I don't care if no one's ever seen a math problem in their life, they can tell that this 1 over sine equals 1 over sine. Right? It's obvious that those two are equal because they're the exact same picture. All right? That's how I know I'm done. 1 over sine equals 1 over sine. So it's obvious the left side equals right side. Well, I didn't have to go this route. Maybe instead, I want to divide both sides by cosecant, or I'm sorry, by secant. So then I'll get cosecant over secant. Well, cotan is cosine over sine. This is 1 over sine. That's 1 over cosine. So this is cosine over sine. So this is cotan equals cotan. All right. And again, I can stop here because anyone off the street can see that these two are equal. It's the same picture, equals are on both sides. All right. So when you verify, you can stop when it's obvious the left side equals the right side. Okay. So again, a couple ways to do these, and there's actually another way to approach these. You'll notice that I kept the equal sign and I worked on both sides. And then I stopped when I figured out the left side was equal to the right side. Okay. You can also, if you want, another way to, to prove things is to actually start from the beginning. So let's start at cosecant cotan, and let's just work our way through and see if we get a secant. All right. So we actually start in the beginning and see if we can come to the end. All right. So, well, cosecant over cotan, cosecant's 1 over sine. 1 over cotan is tan, or 1 over cotan is tan, right? And then I'll change tan into sine over cosine. I'll divide out the sines, and I'm left with 1 over cosine, and 1 over cosine equals secant. So I had to do all the work I started at the beginning, and then I worked all the way through. So I just proved that cosecant over cotan equals secant. So this is a proof that this verifies the identity. Okay, so you're free to do whichever way you want. You can work on both sides at one time and keep the equal sign and do, kind of that equation, those equation operations where you do it to both sides, or you can start at either the left or the right and work your way until you get the other side. Okay? All right. Okay, so you want to stop this and complete class or problem number 7. All right, so now here's our last set of these, and this is where it gets kind of complicated. So this is the idea where, yes, I could do where I just talked about, where I do the left side and I try to get it to come out to be the right side. It seems kind of complicated, but you could try it. This is the case, though, where this looks incredibly complicated, but you'll see if I do one simple thing, I'm actually going to kind of open up a lot of possibilities. So when I see complicated things like this, I'm always thinking, well, I don't like the denominators. So should I multiply through by sine squared, or should I multiply through by cosine squared? Well, if you multiply through by sine squared, right, you get a sine squared and then secant's cosine, 1 over cosine. So sine squared over cosine, and then you'll get a sine squared, and this is a sine squared, so those will divide out. So maybe it's not a bad idea. So on these kind of things, you try it. So if it looks like it's a good idea, you try it. I like the other idea that cosine, because I'll get a cosine squared over sine squared. Then I know that's cotan squared. This is 1 over cosine, so that's nice. So I'm actually going to go the cosine route. So let's multiply everything by cosine. And then you'll see cosine times cosine would be a cosine squared. These divide out to be 1, and then these divide out, which was the point. So I'm actually going to get cosine squared over sine squared plus 1 equals cosecant squared. Well, now it's looking real good because we have an identity of squares and 1, so this could be a Pythagorean identity. So cosine over sine is cotan, so that'll be cotan squared since these are both squared. And there you go. Here is our identity. And now here's the last step, right? This is not obvious that left side equals right side because someone walking in off the street couldn't tell. But we know that cotan squared plus 1 equals cosecant squared. So my last step is to say, hey, look, cosecant squared equals cosecant squared. Right? And now it's obvious left side equals right. So this case, I'm not saying that we couldn't have started with the left side and developed the right, or started with the right and developed the left. But on things like this, I like to use the equal sign. Because again, one quick step of cosines, and it really made this problem quite easy. Right? Okay, so that's it. I'm going to stop the video and complete the rest of the classwork.